Okay, so what we're going to do right here is we're going to try and figure out what's going to happen to the reaction and which direction are things going to go. So let's just take a closer look here at the actual equation. And if we look at the equation here, they're giving us 75 millimoles of this, and they're giving us 75 millimoles of this. And we have nothing else. So we have a container, and inside that container, we have the CH4 and we have the H2O, which looks like blobs the way I'm writing it right now, but that's all we have. So if we're thinking about this just reasonably, the only direction the reaction can go if we start off with 75 millimoles of both, wouldn't it be in this direction right here? So what we're going to do right now is they're going to ask us a series of questions. So let's look at them one by one and see whether or not which ones make sense. So it says, what is the rate of the forward reaction before any CH4 or H2O has been added to the flask? In other words, what they're saying is, hey, do you understand that if you have nothing in here, that nothing is going to happen? And so your short answer, it has to be, there's going to be no forward reaction. There's going to be nothing going on. Why? Because there's nothing in the reactant side. So I'm not even going to look at the other options here. But now we're going to go to the next one. It says, well, what is the rate just after the CH4 and H2O has been added? So the instant we add the CH4 and the H2O in there, the reaction is going to start going like this, right? So when we take a look at our choices, what is the rate of the forward reaction? Well, it can't be zero because clearly the reaction is going. Greater than zero, but less than the rate of the reverse reaction. What that's saying is this, and remember, this is important. As the reaction starts to go in this direction, as soon as you have products, a little bit of it's going to start going back the other direction. So the forward rate is going to be much greater until the rates even themselves off, and that's what we call equilibrium. So if we, I was looking at the wrong question here, but all the choices are the same. What is the rate of the forward reaction just after the CH4 and H2O have been added? Well, it can't be zero. Greater than zero, but less than the rate of the reverse reaction? Well, the reverse reaction's almost nothing, so that's no. Greater than zero and equal to the rate of the reverse reaction. The only time that happens ever is when the forward and the reverse rate are equal to each other, so that's a no. And then we look at this and it says greater than zero and greater than the rate of the reverse reaction. So the key phrase right here is just after the reaction has started. So I'm going to go over here and go like, well, this is their only answer option that makes sense. Now, again, this is understanding equilibrium, and it says, what is the rate of the forward reaction at equilibrium? Well, the forward rate of the reaction at equilibrium is going to be equal to the reverse rate of the reaction. So we can scroll through here and go, well, it can't be zero, greater than zero, but less than the reverse, greater than zero and equal to the rate of the reverse reaction. And there's our key phrase, equal the rate of the reverse reaction. Greater than zero and greater than the rate of the reverse reaction would mean that we're going more in this direction. So again, in this case here, we can just do a quick little check here and go, it's got to be equal. And then it says how much CH4 is in the flask at equilibrium. So we're looking for this guy right. Oops, did not mean to do that. Didn't mean to do that either. Let's try this one right here. We're looking to see how much of this we're going to have at equilibrium, right? So we know that the reaction is going in this direction, right? So we're going to have less than the 75 millimoles of CH4 than we did to begin with, right? So when we look at our options here, how much CH4 is going to be in the flask? Well, remember, from doing previous problems, you're never going to have all of the reaction go because every time you have a reaction going, at least a little bit is going to go back in the other direction. So in this case right here, the idea that there's none is no good. Some, but less than 75 millimoles. Well, remember, we start with 75 millimoles of this, right? So some of it's going to go across. We know that there's going to be less than 75 millimoles. So this one here looks like a check mark for us. Exactly 75 millimoles means that what we started with up here hasn't changed. More than 75 millimoles means that we started with this, and then through some miraculous creation of matter technique, we ended up with more. So the only answer that really fits for us here is the sum, but less than 75 millimoles. Hopefully this has helped you.